Bismillah ar-Rahman ar-Rahim. In the name of Allah, most gracious and most merciful. How are you everyone? Inshallah, Rabbil Alameen, you are doing well. طبعا I sent you a preparatory online assignment. Okay, this online assignment is preparatory. It means I ask you to look at these questions because this will prepare your mind, inshallah, Rabbil Alameen, to be more or to be looking forward to knowing about what I'll explain, inshallah, Rabbil Alameen, this period and the next period. Okay, and today also you will find another preparatory online assignment. Okay, all both online assignments are past papers questions. Inshallah Rabbil Alameen, starting the next week, we will make the periods of Wednesday and Thursday for solving past papers on topic 4, because we will begin take past papers on topic 4. Okay, and now inshallah let's go to finish what you want to say, or say what you want to say. Okay, last period we saw that the magnetic material and the non-magnetic material, and we said that the magnetic material is the material. It's, in fact, it's not a magnet, but it can be, number one, it can be magnetized. Number two, it's attracted to the magnetic field. Okay. Welcome, Umair. Welcome back, Umair. I hope you are in the school or in the or online, Umair. Tell me on the chat. Okay. So, and we gave examples of the magnetic material. We said the magnetic materials are not magnets, but they will be magnets if they are magnetized. Okay, the magnetic materials can be magnetized. The magnetic materials are attracted to the magnetic fields. The non-magnetic material is the opposite. Okay, let's remember that we said examples of magnetic materials. For magnetic materials, we said several examples. Okay, the most famous and important examples are two. One is the iron, and we said this is soft material or magnetically soft material, and it's also called the soft iron. And the other is the steel, and the steel is magnetically hard material. What's meant by magnetically soft and magnetically hard? Magnetically soft means it's easy to be magnetized and easy to lose its magnetism, or the opposite. I'm waiting for your answer. If you say yes, write 1. If you say no, write 2. Say it's easy, write 1. If you say no, write 2 in the chat. I'm looking at the chat. Thank you, Noor Awab. Thank you, Siraj. I'm asking about the magnetically soft material. Is it easy to be magnetized and demagnetized, or hard to be magnetized and demagnetized? This is my question. Okay, thank you. Okay. Abdullah Lifi, thank you also. Okay, Umair, I hope you are you can hear me. Umair, can you hear me? Okay, concentrate and focus on each word that I'm saying now. Okay, because this kind of revision is I know that this your first time. This is your first time to join today. Okay, so the soft material is magnetically hard, so it's difficult to be magnetized and difficult to demagnetize. We said that steel is a magnetic material. It's a hard magnetic material, and the stainless steel is non-magnetic material. So we have to differentiate between 3 things, as we said, between the iron, which is magnetically. Are you joined online in the class? طيب تمام يا عمير. Okay, alhamdulillah, كويس قوي. The iron is magnetically soft. The steel is magnetically hard, the stainless steel is non-magnetic material. Okay. Now, inshallah, Rabbil Alameen, and at the end of the period, before, by the way, the router cuts off power suddenly. Okay, at the end of the period, alhamdulillah كان فاضل دقيقة ولا حاجة يعني. تمام. طيب. So this is last period, يعني at the end of the last period. Okay. Before cutting off the internet last period, I said that we will use the magnetically soft in temporary magnets and the magnetically hard in permanent magnet. Okay, now inshallah Rabbil Alameen, let's say important notes or some important notes, some important notes. Number one, magnetic materials are also, or can be called, ferrous materials, or ferromagnetic material. Ferrous material or ferromagnetic materials. Okay. In fact, there is slight difference between the two terms, like in our syllabus, they are considered to be the same, but this is not accurate. Okay, so this is the first point we want to talk about. The second point we want to talk about is the permanent magnets, okay, and the temporary magnets, okay. What is the difference between them? First of all, we said magnetically soft, are used to make temporary magnets, but magnetically hard materials are used for the temporary magnets, and the magnetically hard are used for permanent magnets. Okay, so this is a very important point. This is a very important point. Well, the temporary magnet it works as a magnet fast and stops acting as a magnet fast. Okay, so we use it when we want to turn on and turn off the magnetism fast. Okay, so We use them when we want to turn off and turn on and turn off the magnetism fast, like in electromagnet. Like in electromagnet. In electromagnet, once we turn on the electricity, it acts as a magnet. Once we cut off the current, it stops being magnet. So when we turn on the electricity, it acts as a magnet. When we cut off the current, okay, it stops acting as a magnet. طيب. What is the use? طبعا made of what iron? Mainly soft iron. Not only iron, but mainly soft iron. Okay. Some uses like number one, transferring, to transfer metallic objects, or you know, the metallic objects by cranes. Like cars, if we want to transfer a car from a place to a place by a crane, okay, we will bring the اتفضل يا نور. اتفضل يا نور. You want to speak, or you will write in the chat? طيب. Okay. Hello.
Mr. I'm sorry, I'm a little bit confused, Mr. This note, Mr. You write something yesterday. Is this a complication, or this is something new, Mr.? You wrote yesterday, Mr. The electric charge, Mr.
Again, معلش.
Mr. What are you writing now, Mr.? Is you completing what you do yesterday, or this is something new? I'm a little bit confused. Sorry.
Yesterday we talked about the magnetic materials and non-magnetic materials.
Yeah, Mr. I wrote them. I mean, now what are you writing now? Are you complete? This is something new?
Not something new. These are some important notes on what? On magnetic materials and non-magnetic materials. Yeah,
Mr. I mean, should I write them?
You have to write them. Anything which is written on the board, okay, should be written in the copybook.
Okay, Mr. Thank you, Mr.
You're welcome. Okay. طيب. Look here. We said also we can use them in, we can use the electromagnet in, we can use it in transformers. What's meant by transformers? Not the transformers of Space-Tune, okay? No, they are the transformers, the electric transformers. We will study these transformers, these devices in topic 4, okay? They increase or decrease the voltage, okay? We can also use them to, or in fire alarms. Fire alarms, okay? And there are several uses also. What about the permanent magnets? The permanent magnets, like the bar magnets, the normal bar magnet, like the normal bar magnets, they may be bars, or horseshoe course, show shaped, U-shaped, and so on. This is the shape. Okay, they mainly are made of steel. Okay, some uses of them, like number one, in the refrigerator or the fridge doors. You know, when we close the door, there is we need some magnet to keep the door closed. Okay, this is a permanent magnet. This is a permanent magnet. Okay. Also, electric motors. Electric motors should be permanent magnets. Okay. Also generators and so on. Okay. Well, so we talked about this point. I think it's just kind of memorization. I mean, nothing to be explained and requires details or something like that. But if you have any problem with this part, please raise your hand and ask your question. Okay. If you don't have, let's continue talking about the magnetism to go forward. طيب يعني كده ان شاء الله مفيش question. ممتاز. Now ان شاء الله we will say another important, another point, which is number 3. This point is related to the permanent magnet. The permanent magnet is it has two fixed poles. At its ends or terminals. Remember, I said fixed. Such that if we suspend it or hang it like this, okay, imagine that this is some clamp or something like that. Okay, if we hang the magnet from its midpoint like this, such that it rotates freely, what will happen? We will find a very famous phenomenon. We will find that one of the two ends of the magnet, which is colored blue, will be directed in certain direction, and the other end, which is colored with red, will be directed to the other direction. The one with blue will be directed towards the geographic south, and the one which is red will be directed towards the geographic north, towards the geographic north. Okay, if you repeat this experiment several times, the same end will point at the same direction each time. And this is the idea of making compass. Okay, this is the idea of making what? Of making compass. Compass. Okay. So we have two poles here. The first one is N pole. The second one is S pole. N pole means geographic north seeking pole. And the S pole means geographic south seeking pole, because each end will point at the same direction. And this is the idea of what, ya jama'a? Huh? The idea of what? I'm waiting for answers. Huh? The idea of compass. This is الشات مش راضي يفتح معلش. The idea of compass ممتاز سيرج ما شاء الله. This is the idea of compass. So here I write by repeating it always take the same direction. Okay, so this is the idea of compass. What is compass, mister? Compass is a tiny magnetic, a tiny magnet or needle, magnetic needle, rotates freely, such that its N shows geo north. Geo means geographic, and its N shows two things: the geo north and the direction of the field. Shows geo north and shows the direction of magnetic field. Is it clear now? So these are two things shown by the N, the geo north, and the direction of the magnetic field. Is there any question in this point? Ahmed Osama Khalid said, Mr. You said permanent magnets has two fields. No, not two fields, two poles. Also, does it mean the soft magnet doesn't have two fields? لا, they have two fields, but not fixed poles. Okay, Noor, تمام. The east and west are known relative to the north and south. يعني when you know, Siraj, this is regarding your question. When you know the east, you will put the east in front of you, the north in front of you. Okay, then the east will be to the right, the west will be to the left, and طبعا the north is behind you. Okay, so this is the idea of compass. طيب again في حد عنده مشكلة هنا؟ أحمد أسامة خالد. How? Okay, I'll explain this point يا أحمد. Don't worry. تمام؟ لكن the idea of compass والكلام ده, is it okay? It's okay. يعني skip this point يا أحمد, because this is my point, my next point. Okay? So regardless this point, is the other points are the other points clear? For everyone, is there anything except for this point of Ahmed? Because I'll explain this now. This is my next point. Okay. So is there any problem? If you have any problem, write 1. If you have any problem, write 1. Noor, the point number 3. Shuf, look, Noor. This is a magnet. If this is a magnet, if we hang the magnet by a thread from its midpoint and we hit it and leave it till it stops spontaneously, لوحده كده من غير ما حد يعمل له حاجة, it will take this direction, for example. I'll find that the red part of the magnet is always pointing towards the geographic north. The S part of the magnet is always point to the geographic south. Okay, طيب, maybe something which happened يعني قدرا, يعني or as they say بإذن الله. لكن if we repeat the experiment, okay, it may change. Let's repeat. If we repeat the experiment again with the same magnet, or with any other magnets in the same point, the red end will point always towards the geographic north, and the S end will be always pointing at the geographic south. So we called the red end as N pole. N pole means geographic north seeking pole or end. And the S pole means geographic south seeking pole. Okay, you get the idea? حاضر يا أحمد, حاضر, عينيا الاثنين. تمام؟ ممتاز. Okay, طيب. Why? We will explain why, but not now. Okay. So we use a tiny, 2 small magnetic needles, okay, as a guide that help us to detect the directions in deserts or skies when we are traveling or something like that. But now we have the GPS. I'm not talking about this point. I'm talking about the ancient use. Okay, so we have 2 small magnets. Okay, this small magnet rotates freely on some tip. Okay, when it rotates, when it stops, its red part, or its N part points to, shows me two things. Shows me the direction of the north. So by detecting the direction of the north, I can know what is where is the east, it will be to the right. Where is the west, it will be to left. Okay, well, طبعا south is behind me. This is number one. Number two, it shows the direction of the magnetic field, because the direction of the magnetic field is the same direction where the N pole of the compass points at. Okay, till now, is it clear or not? ماشي يا احمد، انا كده بجاوبك على سؤالك اهو يا نور. سوري. Is it clear? ممتاز، واحمد كويس كده، الكومباس ظبطت الامور معاك. اتفضل. Okay, you can ask your question. I'm waiting for your question. You want to take the mic? اتفضل.
Mr. I have a question. If you, Mr. first make the experiment that you make the red to the right and the blue to the left, and then you make the experiment again, Mr., but you make the blue to the right and the red to the left, will it make the same? Like the red will be up and the blue will be down, and if you make it and if you
Okay.
And if Mr. if you turn it, everything will be the same or not the same.
The general answer: put the magnet in any position you want to put it in it, but in the same place. Okay. Yeah. It will rotate till it balances in this direction, in this situation in front of you. So it always will come back to the same situation, such that the red points to geographic north and the blue points to the geographic south. It's not, thank you. You're welcome. It's not an experiment in our syllabus. If it's experiment, I will tell you it's an experiment. Okay. No,
I mean, Mr. Like, I don't mean experiment. I mean like someone's trying to see what will happen.
Tamam. Okay. Well, so now we got this idea, and this is the idea of the compass. Inshallah, I mean, I think it's inshallah so clear. Okay. Type, Mr. What is the single case where this magnet deviates or deflects, okay, from this direction? If we put anything that produces magnetism beside it, yani if we bring anything that produces magnetism, magnetic field, and we put it beside it, so it will make some kind of interruption, okay, so it will not take the same direction. Like if it's hanged freely far of any of the effect of any neighboring magnet, it will take the same direction always. Tamam? طيب. Is there any problem? If all is correct, please write one. بس fast لو سمحتم. Thank you, Noor. يا جماعة, I'm waiting for you. If there is something which isn't correct, write two. Where are the others? What's wrong with you, Siraj? Tell me. Yani, what are you waiting for? Tell me.
Maybe Mr. He's writing the question, or he's writing a question.
طيب ما هو انت يا اما تكتب يا اما raise your hand عشان ادي لك المايك. They are not two magnets, yeah, Siraj. This is a single magnet. When you catch a magnet, yeah, Siraj, the magnet itself, okay, has two sides. One is colored with red and the other is colored in blue. This is one bar. This is a single magnet. You get the idea? يا جماعة, it's important to ask. يعني شوف هنا هو, when he asked about the point, I discovered this misconception. Okay? طيب. Is there any other question? Everyone in the class, please. If you understand, write 1. If you don't understand, write 2. Thank you, Noor.
Mr. I understand, Mr. Your summary that you made, Mr. is very good.
طيب الحمد لله. تمام. Thank you, Ahmed Usama Khalid. Where is Umair? Where is Abdullah Lefi? Am I talking to myself? It's not logic. Well, تمام. Okay, inshallah Rabbil Alameen, we will stop here and next period, inshallah, we will continue talking about the magnetism. Thank you, everyone. Assalamu alaikum. You're welcome.